Alright, so for my physics problem, I chose a goal kick, so I'll just read it out. So I'm taking a goal kick 5 yards out that just reaches the 50-yard line on a 100-yard field. So if I kick the ball, giving it a speed of 22.35 meters a second at an angle of 31.32 degrees from the horizontal. So I'll just underline some important things to keep in mind. I'm kicking the ball at 22.35 meters a second at an angle of 31.32 degrees. I'll go in the picture in a second. And also something important is 5 yards and 50 yards because I'm going to be finding the angle between that. So I'll go into more detail in a bit. So what I'm trying to find is find the speed of the ball as it reaches the 50-yard line and how high was the ball at the 50-yard line. So just to give you guys a little picture, this is anyone, it could be me. I'm going to kick the ball. It's going to be at an angle of 31.32 degrees, and it's going to go all the way to the 50. So that means its initial velocity is going to be 22.35 meters a second. So the first thing to do is we're going to find the displacement from the 50, or from the 5 yards to the 50 yards. So we're just going to we're going to subtract 50 minus 5, and we're going to get 45 yards. So once we change the 45 yards to meters, we'll just do conversion. So this will cancel. 1 yard is 3 feet, and then 3.28 feet is 1 meter. So once we get all that, we'll get the displacement equals 41.15 meters, and that'll be for the horizontal. So I'll just write that in. 41.15 meters. So some other info that we could just fill out is that the horizontal acceleration is 0 meters a second squared, and also that the vertical is negative 9.8 meters a second squared. We can't really fill out anything yet, so after we do step 3, then we could start filling out the initial and final. So the next step we'll be able to do is, since we have this initial velocity of 22.35 meters a second and this angle of 31.32 degrees, we can make that into a triangle and find the horizontal and vertical velocities, both initial. So to do that, I'll just set up a triangle like this, and the first step to do would just be the sine of 31.32 degrees would be the opposite over the hypotenuse, so it'll be y over 22.35 meters a second. And to get rid of that, you could just multiply by 22.35 meters a second, and then 22.35 meters a second, and you'll get, for your y initial velocity, for your vertical, it'll be 11.62 meters a second. And then same thing, but now since you're trying to find the horizontal, you're just going to do 31, you're going to use a cosine, because cosine is adjacent over hypotenuse, so you'll just do cosine of 31.32 degrees is x over hypotenuse, which is 22.35 meters a second. Same thing, multiply by 22.35 meters a second to get rid of that, and then you'll get x equals 19.09 meters a second. So we could fill that in now. So for my y, I got 11.62 meters a second, and then for my horizontal, I got 19.09 meters a second. And these two would also be the same thing, so I could just fill that in quick. 19.09 meters a second. And with that information, I could use that to find my time. So I would use this formula, the displacement formula, and I could cross out this right here, since I know my acceleration is 0 meters a second squared. So that makes it nice and simple. I could just plug in the 41.15 meters equals 19.09 meters a second times time, divide by 19.09 meters a second, and I'll get time equals 2.15 seconds. And then I can write that in, 2.15 seconds. and it'll be same thing for both. And now all I have left is to find the final velocity for horizontal and the displacement for horizontal. And those two will be the last thing I have. Alright, now that we have all this information, we could find the final velocity, and we would just do that by using the acceleration formula, which is acceleration equals final velocity minus initial divided by the time. So we were just plugging our values only on our vertical side, so that'll be negative 9.8 meters a second squared equals final velocity minus the initial, which is negative 11.62 meters a second, and divided by time, 2.15 seconds. And we could just multiply by 2.15 seconds to get rid of the denominator. And that done out, you can see as the seconds cancel, and it'll just be meters over seconds. So once you negative 9.8 times 2.15 is negative 21.12 meters a second, and that'll be equal to the final velocity minus final velocity minus 11.62 meters a second. And from there you can just add 11.62 meters a second and add it to the other side, and you'll get a final velocity of negative 9.5 meters a second. And I'll just fill that in here. So with this information, now we can finally solve our first question, which was find the speed of the ball as it reaches the 50-yard line. So we could start by using the final velocity of both now. For the horizontal, it'll be negative 19.09 meters a second, and for the vertical final, it'll be negative 9.50 meters a second. So with that, we could use the Pythagorean theorem, a squared plus b squared equals c squared, and we could get a value, which is c roughly about 21.32 meters a second, and that'll be the first answer to our question, which is A. So that's the speed of the ball as it reaches the 50. So this will be the 50-yard line, 50 yards, and that'll be the speed of the ball as it just reaches the 50-yard line. And the last step, we just need to find the distance, that little distance right there. And we could do that now since we have all the information. So we'll just use displacement, and again, only sticking to this side. The initial will be 11.62 meters a second times the time, 2.15 seconds, plus 1/2 of the acceleration, which is negative 9.8 meters a second squared, times the time squared, which is 2.15 squared. And these seconds will cancel, and also these seconds over here on this side will also cancel. So it'll just be all in meters, and you'll get displacement equals 24.98, and it'll be meters, minus 22.65 meters, and you'll get roughly about the displacement from the 50 above the ball above the 50-yard line will approximately be 2.33 meters. And this is the answer to the second part. So, and that's pretty much it. So these are the two things we were looking for, and we found them.